My talk will be in three parts. In the first part, I'll start by telling you what we know about climate change in Malta. Then we'll look at the evidence so far, evidence of climate change already happening in our islands. And then we'll look at the predicted impacts of climate change on Malta in the future. Okay, so what's the state of knowledge about Malta, first of all? Very, very few scientific studies that have made it into international journals. And actually there's little that has been done in Malta. There are a number of reports and in grey literature, such as the National Communications of Climate Change to the UNFCCC. There's 6 of them up till now. And this latter study is the only one that actually involves modeling. Now, when we talk about modeling, it's a development of a mathematical formula which predicts events. It has nothing to do with the catwalk. So basically, this kind of modeling is used to predict how weather patterns will change in the future and how the likelihood of particular events happening. For instance, the likelihood of extreme events or sea level rise, for instance. These are some of the main studies that were carried out on Malta. Okay, there's the first half were published in journals, and then the others are mostly in grey literature. So what do they say? First of all, most of the knowledge we have is based on assumptions, okay, on assumptions of what might happen. And as I said, there's only one study that actually tries to model a change in climate. The problem with modeling is that mathematical models are very complex, and you often, to develop a model, you need a group of scientists with many, mostly mathematicians, focusing on one issue. And the models which we currently have are larger scale models, for example, for the entire planet or else for different regions. And then what they do is that you take a regional model, for example, a model for the Mediterranean, and then you have to downscale it using, again, mathematical tools to a particular area to increase the resolution, okay? And because Malta is so small, it's very difficult to reach the resolution which is necessary to make some sense out of a modeling study on Malta. So basically you might end up with just 1 pixel on the entire island, okay? And that doesn't really make much sense. Or else you might end up with half of the pixels being part of it on the sea and part of it on land. So that's not very accurate either. There are a few studies, though, that look into more detail on certain aspects, for example, the health sector. And we're going to see some evidence from them. So let's start looking at the evidence. So this is a graph showing the average air temperature, the annual average air temperature, increasing from 1923 to 2005. So this is actually based on records. And if you look at the average, you see that the average has increased, the slope is increasing. So there is an actual increase in temperature. Some of you might have heard that before climate change actually happened, we were supposed to enter an ice age. And then because of the increased levels of carbon dioxide, the temperature then went up. And that's what happened here, okay? This is when climate change actually started to kick in. In this chart, we took the annual average temperatures and divided them according to the seasons. And you can see that in some seasons, the temperature, the increase is higher. For instance, in summer, the annual increase in temperature has been higher, okay, compared to spring and winter. And the lowest increase in temperature has been in autumn. This graph shows the number of rain events, basically, the number of days where rain fell on the islands. And there's a gradual decrease in rainy days from around 87, 88 down to 80. Okay, this is what was until 2005. This graph shows the annual highest precipitation over 24 hours. So you take, for instance, let's say in 2007, the rainiest day was 4th April. And on that day, there was 100 millimeters of rain. And this takes into account those events, the rainiest day in the year. And this shows that extreme events, which is basically, it is an extreme event, is leading to higher rainfall on certain days. So you have more rain on one day. This is some data from a paper relating to sea level rise. And between 2002 and 2009, there was a sea level rise experienced in Malta of around 9.44 millimeters per year. Okay, that was a paper from Drago in an international journal. Here again, we stay in the marine theme. We're looking at the sea surface temperatures. And since 1978, between 1978 and 2004, there was a gradual increase in temperature from 19.2 to around 20.5. Okay? This is compared to the time series for the surface air temperature, which was over a longer time span. So the increase in sea temperature has been actually faster. One of the evidences from the appearance of various other mosquitoes, for instance, the tiger mosquito, and this has spread throughout the Mediterranean and even into Europe, whereas before it used to exist up till the Sahara. So what about the future? What do we expect from the future? This is based on one of those climatic models which I mentioned earlier. And here, in this, the first part here, this shows the annual average temperatures, okay, for 2025, 2050, 2075, and 2100. The temperature is going to increase gradually over time. The highest rate of increase is expected until 2050, and then the rate of increase will slow down until we reach that peak. This is what they expect. Of course, this depends on whether we reach the threshold that, I'm not sure if you've heard, but there's a threshold where if the temperature increases high enough that the tundra starts melting, lots of methane will increase, and that will be released, from the frozen Siberian plains, and that will increase further the temperature, and we might go beyond a limit, and that will increase the temperature even higher than that. And there's not much we can do then at that stage. Okay, so as I said, the temperature is increasing at that rate, and the highest rate of increase is in September, okay, where we're expecting an increase in temperature of around 3.6 degrees by 2100. As we're going to see here in this graph of precipitation, there's a lot of signs that the summers are going to increase, and here we have some evidence of this. This graph here shows this is the average change in precipitation. So as you can see, there's a change of precipitation of around predicted between 4% and 2 to 3% below what we have currently. So that doesn't look like much. However, if you divide it according to the seasons, This is the winter season, spring, summer, and autumn. And in winter, there's a very little change or actually a slight increase. Whereas in spring and summer, there's a drastic decrease in precipitation predicted. So between 10%, less than 10%, I mean minus 10%, all the way to over 25% decrease by the end of the century. And in summer, it's worse. Now, this is the percentage change. In summer, the total amount of rainfall is very little. So if there's, usually it's 5 millimeters, and it decreases by 1 millimeter, that's 20%, okay? However, the significance in this is that spring rainfall is going to decrease, and that's going to lead to a lengthening of the summer season. So we'll have a longer summer and more months without rain, as is happening already. These predictions come from the Second National Communication on Climate Change. And these letters refer to medium likelihood, an M, a high likelihood of it occurring, and a low likelihood of the event occurring. So with in relation to increased summer temperatures, there's going to be increased pressures on groundwater, for instance. It's a very high likelihood that it will occur, and it's already occurring. There will be an increased demand for potable water because of the longer summers. This will lead to a pressure on the reverse osmosis plants, of course. There will be increased evapotranspiration rates because of the longer summers as well. Then, with regards to lower summer rainfall, we will have a lower recharge volume, okay, the amount of water that reaches the water table. And this will increase the demand from the agricultural sector. Okay, so whereas there's less water available over summer and spring, more water will be needed. The demand will be higher. With regards to increased winter temperatures, there is a medium likelihood that there's going to be a higher demand for potable water. There's going to be increased pressures on groundwater as well. The same with regards to the reverse osmosis plants. And also there's going to be also increased evapotranspiration rates. And if you consider the weather today, February, you can already see that it's happening. These are further impacts. For instance, let's look at this one. Higher intensity of rainfall. This will mean that because there's heavier rain events, you'll have more runoff, for instance, and the recharge of the water table will be less. And sea level rise is expected to reduce the volume of groundwater, and also it will increase the salinity of the groundwater as well. Now, with regards to biodiversity, the biggest at risk are habitat specialists and endemic species. The problem is that if they depend on a certain habitat, whose conditions change, and then this habitat is not viable any longer, the species will be lost, okay? Or else they will have to move. Now, if they're surrounded by other land uses and there's nowhere for these habitats to move, then there's not much hope for them. A particular risk, a particular habitat which is at high risk are the salt marshes, which are found close to the sea, especially the ones which are restricted in size and also bordered by other land uses. And in those cases, with sea level rise, they'll basically be lost, okay, like the one in Marsa Xlokk. With regards to agriculture, as I mentioned, the shortening of the rainy season is a big risk to the agricultural sector. Higher rain intensity will lead to soil erosion, structural damage to the soil, and also water logging as well. Nutrient leaching and also problems to direct damage, for instance, to greenhouses, okay, because of extreme events. Increases in air temperature will also lead to risks in the health of the animal husbandry sector, especially when you have long heat waves, okay, for the animals which are staying outside in the farms or on the sheds. And milder winters will also lead to bigger incidence of disease later on in the next season. Because if the winter temperature is not low enough, pests and diseases will not die out during the winter season. Okay, and of course, higher temperatures are ideal for insect pests, for instance, and they're expected to proliferate in the longer growing season as well. That's all from my end. If there's any questions, I don't know.
First of all, thanks a lot for the presentation.